Good afternoon. The human history is divided into ages, starting from the Stone Age and the Metal Age to the Electronic Age and the Silicon Age. And now we are at the threshold of a new era, known as the Quantum Age, where the rules and phenomena of the quantum physics will rule the world. The first quantum revolution occurred in 1925 and gave us several contributions. And now we are endeavoring into the second quantum revolution, which would begin by this year. It is essential to understand the history and phenomena of the quantum physics in order to understand it. And coming to history, it began in 1900 when Max Planck introduced the quantum theory as a solution for black body radiation. In 1905, Albert Einstein explained photoelectric with this, and in 1930, Niels Bohr prepared the Bohr model of atom with this. These are the people who molded quantum physics into what we see today. Niels Bohr, Werner Heisenberg, Erwin Schrödinger, Walter Rank, Satyendra Bose, and many more. Now, when it comes to the phenomena, wave particle duality states that in the quantum world, waves like electromagnetic waves act as particles and particles like electrons act as waves. Observers state that when we measure, observe or detect a quantum particle, it will show particle nature and otherwise wave nature. While coming to quantum entanglement, it's a phenomenon which states that when two quantum particles interact in a specific way, they couple their properties, that is, the first goes up, the second goes down. They can communicate beyond space and time. Superposition, according to the Copenhagen interpretation, states that until we measure, observe or detect a quantum particle, it's in a superposition of all the possible states. Quantum decoherence is a phenomena when a quantum system will become classical due to the interaction with the classical atmosphere, classical environment. Quantum tunneling is a phenomena stating the probability of a quantum particle doing an activity like crossing an energy barrier without enough energy required for doing it, along with the other principles like uncertainty and exclusion principle. Now let's dive into the main topic, conventions. Quantum computing uses quantum bits or qubits, gates and Fourier transform for calculation, and it has an exponentially higher processing capacity. With the help of quantum annealing, we can find answers to TSP or trading salesman problem, as well as optimize our daily life problems as well as logistics. Quantum simulation is a thing with which we can simulate how particles will interact in specific conditions. This would be useful in space sector for designing new materials for spacecraft as well as fuels. In the pharmaceutical sector, it can be used for designing drugs without having even a trial. In the defense sector also, it will have large possibilities. It can be also used for complex modeling such as climate, economic and social modeling. When coming to quantum network, it's a distant concept with which we can communicate with large amounts of data. This would be useful in space sector for importing the data from space telescopes. Quantum cryptography is the encryption method of the future. Quantum key distribution is an unbreakable tamper-proof encryption technology. It can be useful in banking sector as well as defense sector and in biometric storage. Now when coming to quantum sensors, which are known for its high precision in calculating gravitational waves as well as time waves, they can be useful in places where GPS is not working. Quantum materials are materials which could import specific quantum properties into the macro world. Magnets and superconductors are examples. Emergent particles are particles which emerge due to the excitation of the elementary particles in the standard model of elementary physics. One such is plasmon. The study of it is known as quantum plasmonics, and with the help of it we can create on-chip, ultra-compact quantum network connecting quantum devices as well as plasmonic circuits in quantum computers with beam splitters, interferometers and phase shifters instead of gates. As it could influence electromagnetic field, they can be used in photon sources, detectors as well as boost the energy efficiency of solar cells. They can be also useful in biosensing. Quantum confinement is a phenomenon when we confine quantum particles, they show specific properties. Quantum dots, which are confined in 3 dimensions, are used in QLED or quantum LED screens which have higher resolution. Quantum wires, which are confined in 2 dimensions, can be used in ultra-compact circuits and chips, as well as quantum wells, which can be used in laser fabrication, are confined only in 1 dimension. Quantum teleportation is a distant concept, but by increasing our information transmitting technology, we can teleport objects from one place to another, as well as quantum AI hybrids can give us human brain replica with the processing capacity of quantum computers as well as the thinking of AI. Along with the potentials, there are some challenges too. Welcome to the first and foremost one is cryogenic cooling. Quantum bits are superconducting, and due to this they require cryogenic cooling, and due to this the cost increases as well as it has complex technologies. Public implementation is a very big issue due to this, so there are new methods like quantum clouds. They are only fast in certain activities like TSP, RCS, prime factorization and many more. They can be as qubits are in superposition, they can only provide us a superposition of answers which must be filtered out. Quantum noise or the random fluctuations in the energy and the temperature could influence the computing and could cause errors. So there are new methods like topological quantum computing are arising. The possibility of decoherence when an influencing particle enter the quantum computer is so high. Due to this, the complete quantum system may collapse. Many physical qubits are used to encode one logical qubit, which is an error correction technology, and this will increase the size as well as may become a challenge in the future. When the number of quantum devices increases, there must be an increase in quantum researchers as well as engineers too. If not, it will cause a technical or a talent gap. Though QKD provides us a new encryption technology, it breaks the current RSA encryption system, which uses the prime factorization of 100-digit numbers, as well as in the wrong hands like terroristic group, it could lead to destruction. Minor fluctuations sensed by quantum sensors may not affect us in the macro world. The possibility of decay and decoherence for emergent particles is so high, and due to this there are fabrication limits. Algorithmic mistake in QML could lead to misunderstanding as well as bias. By embracing the potentials and addressing the challenges, we can move on to the quantum world. There are further possibilities like imagine creating an artificial black hole with artificial Higgs field interactive and creating magnetic monopoles with dispersion titanite and transmitting information from future to the past. These are theoretical, but by the implementation of quantum world into the human life,